this video I'm going to go over question 9 from the November 2016 paper 1 for IB Math SL. First two terms of an infinite geometric sequence. So that infinite geometric sequence tells me a couple things. This list goes on forever. They're only showing us the first two terms. And the fact that it's geometric tells me there's a common ratio, which I can always find by dividing any term by the one that came before it. So when it asks us to find r, that's exactly what we need to set up. Any term, so in this case the second one, divided by the term that came before it. This is a 2-point question. Most people were able to set this up. And then it's important to realize that log base 2 of x and log base 2 of x can cancel each other out. They're just a single number, and they cancel if they're stacked on top in a fraction. So this just equals 1/2. So the common ratio, though this sequence looks confusing, is just a half. Show that the sum of the infinite sequence. So because this common ratio is less than 1, there's something in our formula booklet that looks like this in the geometric sequences section. If you have a common ratio whose absolute value is less than 1, so a fraction that's less than 1, there is a sum to the infinitely long list, and there's a formula for it in the booklet. It's the only one that has s sub infinity, and it's the first term over 1 minus the common ratio. So in this case, the first term is 2 log base 2 of x, so just important to check back to the list that that's the first term, divided by 1 minus the common ratio. 1 minus a half is a half, so this is 2 log base 2 of x divided by a half. And many of us are still messing up dividing by a fraction. It's helpful to think about it first as division, because a fraction does mean division. So first, don't flip anything. If you want, write it as a horizontal division problem. And then remember that to divide by a fraction, we can change to multiplication and flip the second fraction. So this ends up just being 2 times 2, which is 4 log base 2 of x. That's what we were asked to show. So now we have shown that that is the sum for log base 2 of x. And then first 3 terms of an arithmetic sequence. So now I see the word arithmetic, I'm thinking these sequences have a common difference. So instead of dividing any term by the term that came before it, you can subtract any term minus the term that came before it. So find D, that's the common difference, by taking any term, subtracting the one that came before it, and we're going to give our answer as an integer. So we're going to take this, so D equals, I'm going to take the second term, which is log base 2 of x over 2, minus the term that came before it, log base 2 of x. So you want to take a second minus the first, or a third minus the second. And then we are expected to apply a property of logs here, which is that if you have 2 logs with subtraction between them, and the logs have the same base, then you can condense the log into a single logarithm with that same base by dividing the arguments. So it's the first argument, which is x over 2, divided by x. And again, we have the complication of how do you deal with a fraction and a division in the same problem. And again, I recommend, this is all still in the parentheses here, writing it first as a horizontal division problem, and then changing it to multiplication. So log base 2 of x over 2 multiplied by, and then flip this one. What you'll see is that the x's cancel out, and what we're actually evaluating is log base 2 of 1/2. And log base 2 of 1/2 is indeed an integer. You're thinking, if the base is 2 and the answer has to be 1/2, what would the exponent be? Because that's what a log expression is, right? It's like 2 to some power equals 1/2. So that power would have to be a -1, and there's our integer value for D. And then the last 2 parts of this question, let S sub 12 be the sum of the first 12 terms of the arithmetic sequence. So an arithmetic sequence cannot have a finite sum if it goes on forever, so you can only do something like the sum of a certain number of terms, in this case the sum of the first 12 terms, and they're asking us to show that S sub 12 would equal this. So if we consult our formula booklet for an arithmetic sum, or the sum of an arithmetic sequence, we're going to see that it's S sub n equals n over 2, and there's a couple versions of this. I like u sub 1 plus u sub n, so the first term of the sequence plus the last term that you're trying to add. So in this case, that'd be the 12th term. So we're going to fill in n as 12 because we're looking for the sum of 12 terms, which means this n is 12 as well. And remember to show that question, we're not using the information they gave us. We're trying to independently obtain that ourselves using the information from the question. So u sub 1 was the first term from the arithmetic sequence, which if I click back a slide, you can see was log base 2 of x. So in this one, it's log base 2 of x. U sub n would be the 12th term, and we don't have the 12th term of the sequence, but we can go over to the side and find it. U sub 12, because there's another formula in the book for finding any term of an arithmetic sequence. That would be to take U sub 1 and add n minus 1 times the common difference. U sub 1 is log base 2 of x. I'm looking for the 12th term, so that would be 11 here, and the common difference is 1. So I can see that the 12th term is log base 2 of x minus 11. And I can come put that in right here, plus log base 2 of x minus 11. And then I can simplify this. So 12 over 2 is 6. Log base 2 of x plus log base 2 of x is 2 log base 2 of x. And then I have a minus 11, and then I can distribute the 6, and I'll get 12 log base 2 of x minus 66, which is what they were asking me to show that s sub 12 equals. So I independently got it, showed all my work for it. And then part E says, given that s sub 12 is equal to half the sum of the infinite geometric sequence, can you find x? So half the sum of the infinite geometric, and we were told that the sum of the infinite geometric, let's click back to that, is 4 log base 2 of x. So half of that would be, and I'll write it down so you can see it, half of 4 log base 2 of x would be equal to 12 log base 2 of x minus 66. So putting together all the expressions they give us. And now we're just trying to solve a log equation. So half of 4 here is 2 log base 2 of x. And I'm going to bring over the 12 log base 2 of x and get the logs on the same side. I can see that this is negative 10 log base 2 of x. I'm going to divide both sides by that negative 10, try to isolate my log. So it's 6.6. And then I'm just going to rewrite this to solve a log equation. Once your log is isolated like this, you can just write it in exponential form. The base is 2, the power is 6.6, and it equals x. And that's how they asked us to write our final answer. If you look back up at question E, it says, write your final answer in the form 2 to the p power, where p is an element of q. That just means that p is a rational number, which here it is 6.6. And that's all.